So in this video, we're going to continue with solving equations, focusing on two-step equations, also known as linear equations, and equations with x on one side. Now, as not only we'll be going through questions involving negative x's, we'll also go through questions involving brackets and questions where you can also see fractions. So when solving any equation, your main objective is always to find the value of x or whatever letter is being used in the equation. So your answer should always be x equals a number or t equals a number, whatever letter is being used equals a particular number. And that number could either be a fraction or a decimal or a whole number or a negative even. Now we do this by trying to get x by itself and on one side. Now though the order in which we remove the numbers that are connected and on the same side as x needs to be done in a particular order, we can use a range of different methods and techniques to actually complete this task. And that is what I'm going to try and go through before we actually go on to some questions. So you've really got to decide which method is going to be good for you, and either or is going to, and I'll identify which ones will most likely get you full marks in an exam and which ones will kind of just give you just the right answer. So the first one is looking at how an equation is built. So imagine that you're always starting with x or a number that you don't know. So for example, if we had 3x plus 6 equals 18, you can read this as I'm thinking of a number which is x, I multiply it by 3, I add 6, and the answer is 18. Now for these solving equations, we've been given the answer, which is 18, and we need to work out what part of the question is, which is x. So we do that by doing the opposite, because typically speaking, when you get asked a mathematical calculation, you get asked a numbers and you need to then process that to work it out. This is kind of doing the reverse. I'm giving the answer and part of the question, and I want you to complete the missing part of that question. So it's kind of like the opposites, and that's the main sort of process that you want to be thinking about when doing these particular questions. So if I start with the answer, which is 18, and I reverse parts of the components, so the opposite of adding 6 is to take away 6, and the opposite of multiplying by 3 is to divide by 3, I should end up with x. So if I do 18 take away 6, which is 12, and then 12 divided by 3 equals 4. So therefore x equals 4. So this is a method of looking at how an equation is constructed, reversing that process and treating it like function machines, which is another topic that you're more familiar with. And it's just a case of looking at starting with the output and working backwards to get the input. But you need to be able to construct in your head how the equation is constructed. So let's have a look at another example. So here we've got 5x minus 8 equals 42. So imagine we're starting with our input, which is x, and I'm multiplying by 5 first, then I'm taking away 8, and my output is 42. So then if I want to go in the opposite direction, the opposite of taking away 8 is to add 8. The opposite of multiplying by 5 is dividing by 5, and that should leave me with x. So if I do 42 plus 8, which is 50, and then 50 divided by 5 equals 10, so x equals 10. Now this is a valid method, and it does work, and it kind of helps you understand particularly writing formulas and writing equations when it's converted from word, and you need to convert it from words to numbers. However, I wouldn't recommend doing this particular method when it comes to, it doesn't really apply to more difficult questions. Like for example, when you get quite a complex equation, like let's say this, then it can be quite confusing as to what you do first. Now, just for argument's sake, what we do is we start with x, then we've taken away 4, then we've multiplied by 3, then I've divided by 8, and then I've added 7, and if I make that equal to y, then to go from y to x, all I need to do then is just reverse the process. So minus 8 times by 8, minus 7 times by 8, divide by 3, and then add 4 in that particular order, and I then work with x. Now this particular method works well when you think about rearranging the formula, so that's another topic in algebra that you may get. So understanding this method is really good, but personally I wouldn't use this technique when solving particularly basic equations. So one thing that is probably encouraged is doing the same to both sides. Now what you kind of need to imagine, as you've got an equal sign on both sides of this equation, it's imagine you've got scales. Now you want to keep these scales balanced at all times. So whatever you do to one side, you've got to do to another. So for example, if I just write out the question, I've got 7x minus 5 equals 16. Now, as I've said, you want to try and get x by itself. So what you need to get rid of first, typically if a question looks like this, is whatever's being added or subtracted. So I want to get rid of this minus 5. Now, how do I get rid of a number is I do the opposite. So what I'm going to do is I'm going to add 5 to both sides so that the scales remain the same. So imagine again, apologies for the drawings. So imagine you've got a scale and you want to keep it balanced at all times. You don't want one to tipple over or one to be more heavy than the other, but there you go. Now from this, the minus 5 cancels with the positive 5, so all I've got on this side is 7x, and 16 plus 5 is 21. Then I look at the 7, which is what I want to get rid of. What's the 7 doing to x? Well, it's multiplying, so the opposite of that is to divide by 7. So if I divide both sides by 7, that 7 cancels with that, so I'm left with x, and 21 divided by 7 is 3. And I've got my final answer. So doing the same with this question here. So here I've got 8x minus 4 equals 44. So I want to get rid of the minus 4, do that by adding 4. So I plus 4 to both sides. And that cancels with that, because obviously minus 4 plus 4 is 0. So I'm left with 8x. And 44 plus 4 is 48. Then I want to get rid of the 8. So the 8 is multiplying by x, so I divide by 8 on both sides. That cancels with that, so I'm left with x equals then 48 divided by 8, which is 6, and there is my final answer. Now another way of looking at these questions is, again, rather than imagining scales, is imagining that the equal sign is like an opposite store. So whatever you want to take from one side to the other, you've got to do the opposite. So the first thing I need to do in this particular question is to get rid of the plus 10. So how do I get rid of that? Is I take it to the other side, that disappears. So what I'm left with is 4x equals, and it's going to be 46 take away 10, which is 36. Then I want to take the 4 over. So the opposite of multiplying by 4, which is what that's doing to x, is divide by 4. So that cancels out. So I'm left with x equals 36 divided by 4, which is 9. And there is my final answer. And then moving on to this next question. Again, I want to get rid of minus 9. So I add 9. And then I've got 6x, and that disappears. So then 6x equals 9 plus 9, which is 18. I then take this to the other side by dividing by 6. Because I'm always doing the opposites, and 6x means 6 times x. So then x equals 18 divided by 6, which is 3. And there is my final answer. And like I said, your final answer should always generally be the letter equals a number. So let's have a look at some general questions. Now, personally speaking, I personally like the last method that I chose, just because it's nice, quick and easy. But doing the things on both sides is probably the more profound way, and probably a method that will take you further when dealing with other methods. So again, starting with question 1, and I'll try and color code these to make it easier for you to follow. So I've got 7x plus 9 equals 23. So again, I want to get rid of the 9. So I take away 9. So I've got 7x equals 23, take away 9, which is 14. And then I divide by 7, which gives me x equals 2. Moving on to the next question, question 2. So I've got 5x plus 7 equals 42. So again, I take the 7 over to the side to make it minus 7. That disappears. So I've got 5x equals 42, take away 7, which is 35. I take the 5 over to the side. That disappears. So I've got x equals 7. And then moving on to question 3, I've got 6x minus 5 equals 31. So again, take the 5 over to the side, so that becomes a plus 5. That disappears, so I've got 6x equals 31 plus 5, which is 36. I take the times 6, opposite of that is to divide by 6. That disappears, so x equals 36 divided by 6, which is 6. And then finally, question 4 for these questions, I've got 8x minus 2 equals 46. Take the 2 over, so that disappears. So I've got 48, and then divide by 8, so x equals 6. Now, if you were to get a question where the answer would be a fraction, then I strongly recommend just leave it as a fraction. If you can't work it out, leave it as a fraction. So for example, if you have absolutely no idea what I'm talking about, so 5 is a bonus question. If I had 2x minus 7 equals, let's say, 5, then here what I would do is, well, that's going to give me a positive number. Let's change that to an 8. So here what we'll do is add 7, which would give me 2x equals 15. And then I divide by 2, which gives me x equals 15 over 2. And I personally, if it's a fraction, just leave it as a fraction. Yes, you could write it as a decimal, as 7.5, but personally I'd leave it as a fraction. So moving on to these questions. Now again, with all of these examples that I'm doing, if you get stuck on a question, match it up with what I'm doing, or match up to an example question that looks very, very similar, and you'll kind of get an idea of what it is you've got to do. Now, the main difference with these two questions is that your x is at the end. So yes, we've got it all on the left-hand side, but what we can do is flip these two things around. So with question 5, I can write it as 3x plus 5 equals 32. And then from this, I can then go through my process. So I take away 5. So I've got 3x equals 27, sorry. And then divide by 3, which gives me x equals 9. Then with question 6, I've got 4. I can swap those two things around. So let me just try that again. So number 6, I've got 5x plus 4 equals 44. And again, all I've done now, again, what you just need to be careful of is the sign of the constant at the front. If there is no sign at the front, imagine that it's positive. Or not imagine, it is going to be positive. But if there's a minus, then it also needs to be a minus. So here, I take away 4. So I get 5x equals 40. And then divide by 5. And x equals 8. Then with question 7, I'm going to swap the two things around. So I've got minus 2x plus 3 equals 5. So again, I'm going to get rid of this plus 3 by minus 3. So I've got minus 2x equals 2. And then I divide by minus 2, which gives me x. So 2 divided by 2 is 1. A positive divided by a negative gives me a negative. So the answer is minus 1. With question 8, which is here, again, I'm going to flip the two things around. So I've got minus 2x plus 5 equals 15. So again, I take away the 5. So I've got minus 2x equals 10. And then I'm going to divide by minus 2. So x equals 10 divided by 2 is 5. I've got 1 negative, so it's minus 5. And there is my final answer. So let's have a look at these questions. Again, very similar, but all in a different order. Now, again, with question 9, as well as I can swap things in order of the sides that they're written on, I can also swap the left-hand side with the right-hand side. So if I just move up a little bit more. So with question 9, as the question is 34 equals minus 6 plus 5x, I can swap these two things around. So I can write it as minus 6 plus 5x equals 34. And then I can then swap these two things around. So it gives me 5x minus 6 equals 34. Now, I'll be honest with you, you're not going to get any extra marks or any marks for going from how the question's written to a way of it being more comfortable for you. It's just for your own benefit. So if you can work out the answer just by looking at the question, brilliant. And it's easily done, and I'll go through what you can do. So for this, all we've got to do there is add 6. So I've got 5x equals 40, and then x equals 40 divided by 5, which is 8. Now, I could just simply work from the question. So again, I want to get rid of whatever's being added or subtracted first. So I add 6. So I've got 40 equals 5x, and then divide by 5, which gives me 8 equals x. Now you can see here I've done this in simply 2 steps, whereas in this first method I did 1, 2, 3, 4 steps I did to get to the correct answer, 8. And again, it doesn't matter whether your 8 equals x or x equals 8, because they both give me the same answer. They both tell me that x equals 8. So moving on to question 10. So I've got 6 plus 11x equals minus 5. So again, I could flip these two things around if you wanted to, but it's again not essential. So I've got minus 5. I take away 6. So I've got 11x equals minus 11. And then I divide by 11. So x equals 1. Now again, don't think that all your answers are going to be whole numbers or nice numbers. Again, it's just pure coincidence that is the case for these questions. So with question 11, I've got minus 29 equals 3 plus 4x. Now that's going to be the same as 4x plus 3 equals minus 29. And again, how I've done that, well, my 4x is positive, the 3 is positive, and the 29 is negative, and that still remains the same in how I've rewritten it. So then going from this, I take away 3, so 4x equals minus 32. I'm then going to divide by 4, so x equals 32 divided by 4, which is 8, and a minus divided by a positive gives me a minus answer. And then finally, question 12, I've got 6x plus 13 equals 25. So again, take away 13, so 6x equals 12, and divide by 2, so x equals 6. And there we go. Now, a question I always often get asked as a teacher is, do I need to show this? Could I just go straight from this line to that line to that line? And the question is, yes, you could. But it's always good for you as a reminder, and also good when checking your answers, to make sure you can see physically what you've done. So it literally takes a couple of seconds. I personally would write it down. So then moving on to the next set of questions. Now these questions involve fractions. Now the process of these particular questions is exactly the same. You remove whatever's being added, subtracted first, and then by doing the opposite. So with question 1, which I'm just going to do in red, so here I've got x divided by 2 plus 11 equals 19. So again, I'm going to get rid of the 11 by taking away 11. So I've got x over 2 equals 8. And then the opposite of dividing by 2 is to multiply by 2. So I get x equals 16, and there is my final answer. Now, the key thing to note is another way of writing this question is a half x plus 11 equals 19, is writing it as a fraction like this. Now, if you have a half x, you can always just simply plonk x on the top with the numerator, and it's exactly the same. So for example, 3 over 2x is the same as 3x over 2. 7 over 4x is the same as 7x over 4. So just something to bear in mind if you do see fractions in any of these questions. So then moving on to question 2, I've got x over 7 minus 6 equals 1. So again, I'm going to add 6 because I do the opposite, and that disappears. So I've got x over 7 equals 7, and then I need to times by 7, so x equals 49. And then moving on to question 3. So question 3, I've got 12 plus x over 5 equals 20. So again, what I'm going to do is just flip these two things around. I like having my x mentioned first. Equals 20. So again, rather than adding 12, we take away 12. So I've got x over 5 equals 8. And then opposite of dividing by 5 is to times by 5. So I've got x equals 40. And then finally, with question 4, I've got minus 2 equals x over 8 minus 5. So again, if you wanted to flip the two things around to make it easier for you, that's fine. But again, it's not needed. So again, opposite of taking away 5 is to add 5. So minus 2 plus 5 is 3. And then to get rid of the 8, I do the opposite. So I times by 8. And so I've got 24 equals x, which is the same as x equals 24. So any of those answers written either way is going to be absolutely fine. Now the last thing we move on to is ones with brackets. Now when you've got brackets, the key thing to do is just basically expand it. Now it's not the only way of doing it, but I would probably recommend that it is one way of doing it. So with one, we've got 3x plus 2 equals 15. So again, you could, now like I said, there's two options you can do. One way is to multiply the brackets, so I get this. The other way is to think about, let's get rid of this 3 and let's take the 3 over to the other side by dividing by 3. And again, you still end up with the same answer. So continuing with this side, I take away 6, so I've got 3x equals 9, divide by 3, so x equals 3. With this one, I've got x plus 2 equals 5, 15 divided by 5 is 3 equals 5, and then I'm going to take away 2, so x equals 3. And you can see I get the same answer regardless of which one I do. Personally, I would say expand the brackets. For number 2, we've got 6x minus 9 equals 12. So again, multiply the brackets, I get 6x minus 54 equals 12. So I get 6x, and again I'm going to add 54, which gives me 66, and then I divide by 6, which gives me x equals 11. And then finally, with question 3, I've got 3x plus 5 equals minus 44. So again, expanding the brackets out, I get 6x plus 10 equals minus 44. I take the 10 over to the other side by subtracting 10, so I get 6x equals minus 54. Then divide by 6, so x equals minus 54 divided by 6, which is 9. A minus divided by a positive gives me a negative answer. So the answer then is minus 9. Now, depending on what level you're working at, you may just get whole numbers as your final answer, but what you need to be aware of is that not all answers are going to be nice numbers where it's all whole. Some of them could be negative, some of them could be fractions, as we've kind of already explained. But the key thing is just remembering the steps, and it's all about doing the opposite. So again, with question 1 on this extension questions, again, I'm going to get rid of the minus 5. And how do I do that? Well, I add 5. So I've got 4x equals 7. And then I think, right, okay, what's the 4 doing to x? Well, it's multiplying. So I need to divide by 4 to get rid of it. Now, when we come to this, we've got 7 over 4, which doesn't go in, 4 doesn't go into 7 nicely. I could convert it as a mixed number, so I could write it as 1 3/4, which is absolutely fine. But I would recommend do not write your answers as decimals. So if your answer is not a whole number, leave it as a fraction. Now, you wouldn't necessarily need to convert it. If it's an improper fraction, then you don't need to convert it into a mixed number unless you're specifically said in the question. Just leave it as, and you don't even need to simplify it unless it tells you. Although it's good practice for you to simplify all fractions that can be simplified. But when you're working with algebra, there really tends to not need be. And I've seen in any mark schemes that you don't get, you may get a mark for simplifying, but it's not really essential. Now, looking at question 2, this isn't really two-step because there's actually more things we've got to do, but the principle is exactly the same. We've got x on one side and we want to try and get it by itself. Now, the question with this is just deciding what you've got to do first. Now, we've talked about always getting rid of what's being added or subtracted. So your initial thought might be to get rid of this plus 5, but actually it isn't. What we need to do is get rid of the last thing that we did to x. Now, this is where understanding and being able to read this equation out rather than just saying 3x plus 5 divided by 6 equals 7, which is kind of helpful because you've got 3x plus 5 divided by 6 equals 7. So when solving this, what we need to do is get rid of the numbers in this order. So I need to get rid of the 6 first, then the 5, then the 3. So from this, I'm going to get rid of the 6, and I do that by multiplying by 6. I do the opposite. So I've got 3x plus 5 equals 42. The next thing I need to get rid of is a plus 5. So opposite of adding 5 is to take away 5. So I've got 3x equals 42 to take away 5, which is 37. and then I've got to get rid of the 3, so I do that by dividing by 3. So x equals 37 divided by 3, and again I can leave it as that because I can't work that out, or if you really wanted to, you could write it as a mixed number, so that would be 12 and 1/3, and there is our final answer. Now there will be some practice questions in a worksheet that I'll attach in the description below, along with their answers for you to check whether you've got them right, and also check your understanding of this video.